Welcome. Today we'll be looking at how to multiply fractions. Our goals will be to be able to multiply fractions, multiply mixed numbers, and verify products on the graphing calculator. Let's take a look at the rule for multiplying fractions. If two fractions are in the form of a over b times c over d, their product is equal to ac over bd. The numerator of the product is the product of the two numerators. The denominator of the product is the product of the two denominators. Seems pretty straightforward. Just multiply across the top, multiply across the bottom. One catch, the final product should be in simplest form. This can be performed either before or after the multiplication process. I would like to take a moment now and explain why this rule makes sense. I'd first like to relate this to what you know about multiplication. You probably remember way back in the day when you were first learning multiplication, you learned that multiplication was just repeated addition. So for example, if I'm looking at 5 times 3, that really means 5 of 3. So we'd have to add 3 to itself 5 times, which equals 15. But it's much easier now to just multiply 5 times 3. If I wanted to model 6 times 4, that means 6 of 4. So you would add 4 6 times. That would give you 24. 6 times 4 equals 24. Now if we apply this logic to fractions, it gets a little more involved, but I think we can still make sense of it. If I want to model 1/2 times 3/5, that means I want half of 3/5. Well, if I model the fraction 3/5, I can't take half of these pieces because there's an odd number of them. There's only 3. But if I take each of these pieces and I cut them into half, I would then have a total of 10 pieces, 6 of them being shaded. Now I can take half of these pieces. If I took half of these 6 pieces, that would leave 3. But now it would be 3/10 because we have 10 pieces instead of 5 to begin with. Now, of course, it's much easier just to use the rule. If I take 1/2 and I multiply it by 3/5, if I multiply the numerators together, multiply the denominators together, of course, I would get 3/10. Okay, now that this all makes sense, let's look at a few more examples and let's just follow the rule. If I want to multiply 2/5 times 3/11, the rule states multiply 2 times 3 in the numerator, multiply 5 times 11 in the denominator, and we would have 6/55. And this fraction does not simplify. Now in this next example, I could multiply across the top and get 60, multiply across the bottom and get 200, but then I would have to simplify that. Another way around this would be to look at the prime factors of each of these terms before multiplying. This is what I mean. Well, 5 is prime. 8 is 2 times 2 times 2 in its prime factorization. 12 would be 2 times 2 times 3. And 25, of course, is 5 times 5. If we simplify this now, our answer will already be in simplified form. Remember, all of these factors will be in the numerator and all of these will be in the denominator. In order for a fraction to be in simplest form, we need to simplify out all of the common factors. So what that means is this 5 over this 5 simplifies to a 1, that simplifies to a 1, and that would simplify to a 1. The remaining factors will be our product, and it will be in simplest form. So on top we would have 3. And on the bottom we would have 2 times 5, so our product would be 3/10. Now these factors aren't disappearing, they are turning into 1s. Just kind of keep that in mind. Okay, 5 times 4/5. Again, the rule says that these both need to be in fraction form. So we have to rewrite this. In order to make 5 a fraction, we can write 5 over 1 times 4/5. And we can easily see now there's a 5 in the numerator, a 5 in the denominator that will simplify. So our remaining factors, 4 over 1, which of course is just 4. Okay, the last example, we have 3 1/9 times 2 1/7. Again, we have to have these written in the form of a over b and c over d. So what that means is we have to rewrite these as improper fractions. So remember, it would be 9 times 3 plus 1, or 28/9, times 7 times 2 plus 1, 15/7. Let's go ahead and factor these into their prime factors. So 28, 2 times 2 times 7. 9 would be 3 times 3. 15, 3 times 5, and 7 is prime. So we identify the common factors. Looks like we have a 7 and 7, 3, 3. Okay, the remaining factors will be our product in simplest form. Let's see, on top we would have 2 times 2 times 5. That would give us 20. And 3 on the bottom, 20/3. This is the answer in simplified form. However, since the original problem was a mixed number, normally you give it back as a mixed number. So let's review how we do that. We would just simply take 20, divide it by 3. So we'd have 6 times 3 would be 18 with the remainder of 2. So what that tells us is that 20/3 is the same as 6 and 2/3. Okay, now I did say that I would show you how to verify these on the graphing calculator. So let me go ahead and open up my graphing calculator and show you. Let's just take a random problem. Let's say I want to multiply 7/8 times 2/3. Well, the first thing I'm going to do is I'm going to put my 7/8 in a set of parentheses, multiply that by 2/3. In parentheses. Now when I hit enter, it's going to give me the decimal answer. In order to convert that decimal back to a fraction, if I hit the math key and then hit enter, that will tell me my product in fraction form. In this case, this would be 7/12. Okay, I hope that helps. Thank you for tuning in, and I hope you have a great day.